at this question from the 2020 Fermat Contest. My hope is that you'll be solving these alongside me. So that's the best way to get some practice with these. So the question says, suppose that n equals 3x plus 4y plus 5z, where x equals 1 or negative 1, and y equals 1 or negative 1, and z equals 1 or negative 1. How many of the following statements are true? Okay, so the first statement, n can equal to 0, n is always odd, n cannot equal to 4, n is always even. Okay, so basically, all three of our variables can either be 1 or negative 1. How many combinations are there going to be? Well, this can have 2 possibilities times 2 possibilities times 2 possibilities. So we can have like 8 different combinations, right? They can all be 1, they can all be negative 1, or some combination of 1s and negative 1s. So let's see if these statements are true. First of all, if they're all just going to be 1, then that's just going to be 3 plus 4 plus 5, which is 12. Okay, so that's why am I doing this? I'm just doing this because it's easy, right? If they're all 1s or negative 1s, it's pretty easy to see. Well, 12, so 3, 1 plus 4, 1 plus 5, 1 is just 12. So this one says n is always odd. So we know that this must be false. Can we make an even number? Can we make it, like, what about the fact that n is always even? Well, let's see. So can it be... Just trying, like, obviously we could just do all the 8 different combinations and see what they're equal to. And that's not a bad way to do this question. Okay, maybe, so can it always be, so why not, let's do some combinations. So 3, 1 plus 4, 1 plus 5, but this time we'll do negative 1. So then we end up with 7 minus 5, that's a 2. Okay, what if we did negative 1 for the 4? So this one plus, so then we have, this is a minus 9, this is a 3, so that's a minus 6. It's still even. And then let's do one where this is it's like this. So that's going to be 8 minus 4 is 4. And then if we do this and 1 and 1, the answer is going to be 9 minus 3 is 6. And if we do this combination, then the answer is going to be is like negative 4, right? Because 3 plus 5, that's like negative 3 and negative 5 makes negative 8, plus 4 is negative 4. And if we do negative 1, 1, and this, then we're going to get negative 7 here, So that's negative 7 plus 5 is negative 2. Okay, and I think we have 2 more left. So we're starting with negative 1 and negative 1 and negative 1. Then that's going to be just negative 12, which is the opposite of this one. So that's all of them, right? I said, yeah. So that 1, 2, 3, 4, 5, 6, 7, 8, that's all of our combinations. And the way I was doing this, I kind of messed up the order of these two should be in the reverse order. If you'll notice, the order I was doing this is kind of like just kind of like if you know like how to add in binary, you know, if you have like if you count how to count in binary, if you have 0, 0, 0, you count, this goes up to 1, and then the next one, because you can't go up to 2, right? Because it's binary, you can't go up to 2. So you flip this one to a 1, that one goes back to a 0, and then you flip it to a 1, and then flip that to a 1, and then you flip that up to a 2. But since this can't go to a 2, this one increases to by 1, which becomes a 2. Since it can't go up to a 2, it goes down to 0, and that one goes up to a 1. So you kind of just do this, and then you get all your 8 combinations. That's kind of the order I was going. So it's good to have an order, like a sequence that makes sense to you, so that you're not creating duplicates. But anyway, so we've created all of our 8 numbers. It's going to be, so 12, 2, negative 6, 4, 6, negative 6, 4, negative 2, and 12. Hopefully I haven't made any mistakes. So we see that it cannot equal to 0. So the first statement is false. And it cannot be 0. We don't see any zeros in our answers. N cannot equal to 4. Actually, we do have a 4 here. So this statement is false. So, and then n is always even. That is actually true. So all of our numbers are even. So I suppose the answer will be B.